Now let's continue with logarithm, and today's lesson will be on rules of logarithm. Now, what is rule number one? Rule number one. This is called the log of products. If I have log m n, this is log m plus the base is a plus log n. So this is called the log of products. So when your two logarithms are being multiplied, it's actually, you can separate them using the addition sign. Number two, if I have log m dividing n, this is log m minus log n, same base. So you call this the log of quotients. Now number three, please remember these rules. You're going to apply them when you solve logarithm questions. If I have log x raised to power n, this is the n will come to the side and become log x. Rule number four, log 1 to a base, could be any base, in this case base a, is equal to 0. Now this is so because a raised to power 0 is equal to 1. Now rule number 5, if I have log a, that means log a to base a, this is equal to 1. Rule number 6, if I have log a or log a raised to power x to base a, this is equal to x. It is so because log a to base a is equal to 1. Rule number 7, if I have a raised to power log x to base a, this is equal to x. Are you wondering how I got this? We got this by taking the log a of the left-hand side. If you take log to base a of the left-hand side, you're going to have log a raised to power log x to base a. And this will be log x to base a log a to base a. Remember? Yeah, that's what you're going to have, because the power will come to the side. And if that happens, you're going to have log x to base a. So therefore, we are saying that a raised to power log x to base a is equal to x. I hope this makes sense. And then this is rule number 8. Rule number 8, I have log b to base a. Now this is the same thing as 1 over, now you're interchanging when you take the inverse. Here the base is a, but here the base becomes b. Why? The a becomes the value of b. There's another way you can write this. You can say log b to base A is equal to, now you give it a common base, let's say x. So it becomes b, log b to base x, divide log a to base x. This and this are the same thing. So, or you write it or express it this way. Now, these 8 roots must be remembered so as to be able to solve questions involving logarithm. So the next step now is to apply these rules. Okay, let's check out number 1 example. Evaluate 1 log 4 times 8 to base 2. Remember one of the rules of the logarithm? That when you're multiplying log like this, here you have 4 times 8, you can express it as different log to the same base. So this is log 4 to base 2. The multiplication sign becomes addition, log 8 to base 2. That's one of the rules. This becomes log 2 raised to power 2 to base 2. 2 raised to power 2 is 4, plus 2 raised to power 3. 2 raised to power 3 is 8. This is 2 log 2 to base 2 plus 3 log 2 to base 2. If you do that, this will be 2 plus 3, because log 2 to base 2 is 1, log 2 to base 2 is 1. And your final answer is 5. I guess that's not a problem. If I have log 64 over 16 to base 4, so what do? Remember the second law, yeah, which is the log of quotient. This is quotient division, like a fraction. So this is 64 over 16 becomes log 64 minus log 16. This will be, because the base is 4, we had to express 64 and indices to have 4, the same to 16. So this is log 4 raised to power 3, which is 4 times 4 times 4, that's 64, minus log 4 raised to power 2, which is 4 times 4, 16. The 3 come to the side, log 4 to base 4 minus 2, 4 to base 4. So this is 3 minus 2, because log 4 to base 4 is 1, log 4 to base 4 is 1. And 3 minus 2, your answer, it's 1. Now let's check out number 3 example. Log 27 square to base 3. So this is log 27 that is squared. Now, it is possible for me to rewrite this to become 2 log 27 to base 3. And this will be 2 log 3 raised to power 3, because 3 raised to power 3 is 27. The 3 comes to the side again, it becomes 2 times 3 log 3 to base 3, which is 2 times 3. That gives you 6. Log 3 to base 3, it's 1. So that's not difficult at all, very easy. Let's look at another one. To simplify this expression, number 4, I'm simplifying. Simplify. Now I have log x raised to power 3, the base is a, plus 2 log x, the base is a, minus log 5x, and the base is a. So if I have a work like this, what do I do? Now, this may look very tricky, but don't be confused. It's the same thing we'll be doing. This is x raised to power 3. This 2 by the side will come here to be the power. After all, it can from this position also come here to be like a coefficient. The minus log a 5x. Remember, the log of products gives you this. So we can express this to the log of product also. By this I mean, I can say using one logarithm, since they are all in the same base, AA, open a bracket, x raised to power 3. The log of product means addition. So I'll convert the addition to multiplication, and then becomes x raised to power 2, because I'm not using one logarithm for these two expressions. The minus is divide, 5x. I hope you catch that. Remember, log of products is addition, so this becomes multiplication. And subtraction is division. You use one logarithm to embrace all of them. After all, I can express what I have here back to this form. Remember, this is plus, division is minus. If I decide to separate each of the term using the logarithm you have there. So at this point, I can divide. And if I do, I'm going to have x raised to power 4 over 5. Now recall, this is log a x raised to power 5 over 5x. So if one of these x should cancel this one, I'll be left with 4, x raised to power 4. Or better still, you can apply indices. If you apply indices, it's going to be x raised to power 5 minus 1, which will give you x raised to power 4. So that's how I got this x raised to power 4. And this is the answer to the question. Now let's look at number 5 example. I'm to simplify 3 log y to base a minus 4 log 2y to base a plus 2 log y squared to base a. Still the same procedure. Express this. The 3 becomes the power raised to power 3 minus log 2y. The 2y will be raised to power 4. And be very careful when you express this. It is not just the y that will be raised to power 4, everything that is here, 2y. Then plus log y squared raised to power 2. How this is easy enough to understand. Now, after doing this, the next step is to express using one logarithm. So if I use one logarithm to express them, I'm going to have y raised to power 3. Minus means division. Divide this, which is 2y raised to power 4. Then plus times y squared all raised to power square. Then you can close your brackets. I hope this makes sense. Now using one logarithm again, I'm going to have y raised to power 3 times 2 times 2, y raised to power 4. Divide. Now let's be careful of this. 2y raised to power 4 means 2 raised to power 4, y raised to power 4. 2 raised to power 4 is 2 times 2 times 2 times 2, 4 times. And that's 16. And then y raised to power 4 is y raised to power 4. So this will cancel this. Y raised to the power 4 cancel y raised to the power 4. So I'm left with y raised to the power 3 divide 16. That's the answer to the question. Very easy, right? Yep. So you're going to do some exercises for me based on what we've been doing. Okay, so you have three questions here. Simplify log x raised to the power 3 minus 2 log x raised to the power 4 plus log 4x. They are all in base A. This is A, this is A, and this is A. The number 2, 3 log 2 plus log 4 minus 2 log 8, they are all in base x. Number 3, 5 log y minus 2 log 3y minus log y squared. They are all in base A. Put your answers in the comment section. Let's see who will be the first to get the questions correctly. And look out for the next class. Further problems involving logarithm.